In the last video that I did, I was having a little bit of problems with this light dependent resistor right here, so I thought it'd be a good idea to test it out. I did a quick test yesterday, but not much came out of it. So here is my other light dependent resistor. This is the one that I actually used in the video, but I thought we should test it first. So all you have to do, this is an LCR meter. So L stands for inductance, C stands for capacitance, and R stands for resistance. And if I just turn it on, the instructions are in Japanese. It's pretty straightforward though. Plus you can go online and get the instructions in English. Just put in like DEREE and DE 5000 and it should pop up pretty easily, especially if you add English manual. But in any case, the capacitance, or the resistance here I mean, is changing because my hand is sometimes getting in front of the light. There's no point zooming in anymore. So it automatically displays the most prominent feature when it comes to resistance, capacitance, and inductance. And you may wonder why the light dependent resistor, it would bother talking about capacitance. Well, I'm going to cover it, and now you can see that this is just an alligator clip cover. The alligator clip is right there. So I'm putting it over there, and right now we got 13 million ohms, 13 mega ohms, drop down to 1012. Now I'm going to really push the cover over it, and we are out of limit when it comes to resistance, and it senses capacitance. And so we can I'll slowly lift this a little bit, little light slip underneath it, and there you can see 90, there's 50 mega ohms of resistance. I'm going to push it down, make it a little darker, and that's 73 million, 95, and there we go, 194 mega ohms. It showed it briefly. And so that's how much resistance we can get when we get it dark, and we can go above 200, it looks like, mega ohms. That's one thing I like about the LCR meter, is the range that you can get. So you can see it's in a slot. There are, you know, clip, or I can't think of what these are called right now, but you can plug probes into it if you have the right probes. And there's also these attachments right here, the blade where the component is right there, and then those go into the plugs. And then I think this is for testing surface mount devices, components right there, and conductive on both ends. So this was not the problem, light dependent resistor. And actually, let's do the bright light, and we're really getting about what I expect. And I think the light is not as bright as, I don't think the battery is new. I think I need to recharge the battery. There we go. That's not too bad. We get 50 ohms of resistance. So I think what might have happened to the other light dependent resistor is maybe I got its resistance too low and it overheated or something. But now we'll look at the one that was giving me problems. And so the problem was I wasn't getting the resistance that I expected for a given light, and it happened suddenly. So I did modify the circuit a little bit, but all of a sudden it didn't seem like it was giving the resistance that it should. And right now you can see we got 0.5 kilo ohms. We had about 12 kilo ohms of resistance with the light the way it was. I'll dim the light, and the camera will adjust, so you might not be able to tell as well. I had to dim the light quite a bit, and I think that's where it was before with the other one at this lightness setting. But now I'm going to put the plug over it, and I'm just going to do this quick. So I'm just putting it over there fully, and there you can see we only have looks like 2.6, now 3.5 million ohms of resistance. So we should have been out of limits, and there should have been charges building up on the side of it due to its high resistance, and we should see capacitance. And it looks like over time it's going up, so that's kind of interesting too. But the other one would have been over 200 million ohms by now. I have this completely covered right there. We will release this. So that was kind of interesting. At some point it will get dark enough, it looks like. Maybe, you know, I don't think we'll get all the way to the millions, but here we set that. That's how I had it on the other one. Looks like we're getting about the same resistance under bright light. I'll try zooming in, which doesn't seem to get as much light onto it for some reason, even though it looks more focused. Right there. So in any case, I think we did get a tiny bit less resistance. So that's what I'm assuming. I'm assuming I got it a little too warm and it slightly altered its properties a bit, and it's really bad. I should have a lot more resistance when it was darker, so I cannot use this in my videos really, other than a modified version. And so in any case, the LCR meter's pretty cool for testing. You just turn it on, it automatically tests what the component is. I do have a capacitor. It's also testing it under frequency. Right now it's megahertz, and we can hit frequency. It was 1 kilohertz, I mean. Now it's 10 kilohertz, and we can zoom in. It's testing it under 10 kilohertz and 100 kilohertz and 100 hertz right there. So you can test it 120 hertz under different frequencies. We'll bring it back to the 1 kilohertz and zoom back. And so I'm going to plug this. We should make sure this is discharged. I'll quickly put it to the same 2 pins of a rail just in case. I'm pretty sure it's discharged already, and there we go. So we got to put it in the right polarity since it's a polarized capacitor. So there's the negative there and the positive there, and I believe it's a, not sure what it is. So it says 50 microfarad, and I didn't look at the capacitance right there. So 50 microfarad. I'm not sure what APO is right there. And let's try some different frequencies. See if I think it usually should have said, oh, we have it to measure capacitance. Let's try to get to auto. Oh well, we can set it to actually measure. So there's the inductance right now, and you can just hit the auto button. Now it's measuring capacitance. Now it's measuring resistance, and I don't know if it was not auto ranging because I hit a button, but nope, it just went to capacitance. So there you can see 49 microfarad. Again, I didn't look at it, and so of course it's 50 volts, and there you can see 47 microfarad right there. So that was its actual value. That was probably far more accurate than what you read on the label there. Capacitors are often higher or lower than their rated value. I think they typically run higher more than lower. There's like a 20% higher chance or a 5% lower chance, I believe, for most capacitors. So in any case, this video ran a lot longer than I intended, but hopefully you still enjoyed it. This is a pretty useful component, not too difficult to work. It's got all this other stuff. You'd have to go online, do a Google search. Hopefully they include the English manual now, but otherwise it's pretty handy. I like it a lot. I don't have to use it a lot though. It's not an everyday use thing. You know, definitely buy a multimeter before this, just any multimeter really. But this is pretty cool if you want to get the inductive, the capacitance, and the resistance property even of these light dependent resistors. So I'll put the light dependent resistor back in there, and there you can see the resistance, and I think it automatically did that. But we can look at the inductance. Again, the current does not stop instantly, even in a resistor. It fights it a bit, and looks like as it warms up, it fights it even less. So I covered it and then released it, and they also have capacitance. They build up a charge across them, and it doesn't look like this one is right now, at least at this frequency. Let's go to 10 kilohertz, and yeah, when it gets darker it looks like it builds up a frequency, but when it's more light on it, it doesn't. And there you go, 100 kilohertz. I kind of expected a little more capacitance to go at higher kilohertz, but as you can see, it even changes over time. So in any case, pretty interesting component, or component tester, I should say, just plug it in, and it'll automatically test it. Plus you can do a few modifications to look at components under specific circumstances. So you can also look at the data sheet. Some of this information will also be on the data sheet for the components, and you may wonder why, but it'll make it a little more understandable after you use the meter and test it yourself, see those numbers. So thanks for watching. I'll see you in the next video.